Welcome back. We're looking at part 2. There are 3 different substances. We want to know if they're ionic or covalent and how they will dissolve in water. Calcium chloride. Well, the key here is that calcium is a metal and chlorine is a nonmetal. Therefore, we know it is an ionic compound. And just remember the distinction for determining metals versus nonmetals is the staircase boundary, separating metals on the left from nonmetals on the right, except for hydrogen, who hangs out with the metals because of that +1 charge it likes to make. It's 1 valence electron, but it's really a nonmetal. So metal in the first position, it's an ionic compound. And when you put an ionic compound, which are salts, into water, they will dissociate or separate back into their ions. Jolly Rancher, you should recognize as being sugar, and sugar is a covalent compound. It's composed of carbon, hydrogen, and oxygen. And sugar will dissolve or dissolute or solvate in water. The molecules do not fall apart. There's no pieces pulled apart from each other, but the molecules are separated by water molecules. And so it will dissolve and disperse, but it will not conduct electricity. There's no ions. And then hydrochloric acid, or hydrogen chloride before it's dissolved, is covalent because hydrogen, even though, like I said before, it hangs out with the alkali metals, is actually a nonmetal. So since this is covalent, or since this is a nonmetal, we know it's covalent. The key for this one, in that it's ionizing, is because it is an acid. It has hydrogen in the front, and hydrogen-containing compounds will ionize. At the bottom, I just wrote a little list of some very common strong and weak acids and strong bases. Okay, you don't have to memorize them or anything. These are typically given to you in problems. Alright, so moving right along. 4 substances: sodium hydroxide, carbonic acid, nitric acid, and calcium hydroxide. Now when I read off the names, it's kind of obvious which ones are acids and which ones are not. Therefore, those are the bases. Easy way to recognize it: OH is in the formula, you have a base on your hands. H is at the beginning of the formula, you have an acid on your hands. Acids, because they have hydrogen, will make protons in solution, because a proton is the same thing as a hydrogen atom without its electron. So we call them proton donors. Bases do not have protons to donate, so they do not. However, they do accept the protons. If they can't donate them, they'll take them. So the bases who do not donate do accept, and the acids which do donate do not accept. Okay? Salts are substances that will ionize or dissociate into ions when they're dissolved in water. These are ionic compounds. Weak acids and weak bases are good buffers, which means they resist changes in pH. For example, your blood is buffered with carbonic acid, H2CO3, and when you exhale, the amount of carbon dioxide and the rate of your breathing regulates the pH of your blood by changing the levels of carbonic acid in your bloodstream. Strong acids and strong bases are good electrolytes, meaning they fall apart completely when they're dissolved, like hydrochloric acid, sulfuric acid. A weak acid is like vinegar, which is acetic acid. Maybe 20% of the stuff will dissociate. The other 80 to 90% of it will remain as the original molecule without donating its proton. Alright, saturated, unsaturated, and supersaturated. I discussed with that graph back there in terms of reading it. Just remember that saturated solutions contain as much as possible at a temperature. Unsaturated solutions, you can dissolve the difference between the line and where you are, and that's how much it will hold. And a supersaturated solution has too much that's been dissolved, so the difference between the line and wherever it's at will be how much will crystallize or precipitate, fall out of solution. Alright, tune into the next video to go through the radioactivity questions.